Hello. Hello, sir. Good morning.
Good morning, Professor. How are you?
Yeah, fine, sir. How are you?
Yes, we are doing good. So all participants joined already?
So, yeah, so around 30 have joined. So, are you able to hear me?
No, there are some disturbance. Can you please be little louder? Yes.
Yeah, so 30 participants have joined, sir. So, I think like it's 9:31. So, we will begin, sir.
Sure.
So, before going further, like, yeah, am I audible now?
Yes, sir.
Yes, sir.
So today we have Professor Partha Pratim Roy from IIT Roorkee. So I'll just mute the. Professor Partha Pratim Roy is currently working as a associate professor in IIT Roorkee. So in the Department of Computer Science and Engineering. He received his master's in 2006 and PhD in 2010 from Universitat Autónoma de Barcelona, Spain, and he did his postdoctoral research in France and Canada from 2010 to 2013. And he also has an industrial experience while working in TCS and Samsung. And he was a team lead in the computer vision research team in Samsung, and he was the recipient of a best student paper award in international conference on document analysis and recognition in Spain. He has published more than 250 research papers in various international journals, conference proceedings. He has co-organized several international conferences and workshops, and he has been a member of program committee of a number of international conferences. He's also a reviewer for many journals in his fields of interest. And his main research interests are pattern recognition, document image processing, biometrics. Hello. Oh, okay, okay. Yes, sir. Please join. Yeah. Yes. So his main research interests are pattern recognition, document image processing, biometrics, and human computer interaction. And he's presently serving as an associate editor of IET image processing, IET biometrics, IEIC transactions on information and systems, Springer Nature computer science. So we welcome Professor Partha Pratim Roy. So, uh, uh, Professor, are you there? He just had a power cut, so he got disconnected. So, just we'll have to wait for a few minutes for him to join. Participants, do you have any queries? Like you can just for 1-2 minutes, you can just interact if you want to ask me anything.
Excuse me, sir. Hello,
Yeah, yeah,
am
please.
I audible?
Yeah, yeah,
Actually, sir,
yeah,
we
yeah.
are the faculty members, so we are having classes also. So sometimes the
Okay.
starting time I may not able to connect. So that's why last 5 session out of 5 session I am having presented only one. So one of the problem we are
Okay.
having that I have to take lectures also. So can
Okay.
it be considered?
I mean, maybe after we consolidate all your attendances,
Uh,
so you can write to us, but then like me and my co-coordinator, so we'll be deciding on whether it needs to be considered or not.
Okay, okay.
So
Actually, what is
yeah,
the matter? I was not aware that only 20 minutes is locking period. That's why I have, okay, I am taking the class, then after the class I will log in. Otherwise, I have to take the login in other computer also. Then on way it can be done this. But most of the
actually,
time,
like
whatever
it
free time I'm getting, other than lectures, I am attending the classes. But
yeah,
joining time,
we understand your we understand your concerns, but from our side, see, ATAL is being conducted by AICTE, and they spend lakhs of rupees in conducting these ATAL programs. And if these programs are bogus programs where like there are no participants, and all participants they just fake their online presence, then it doesn't augur well for the FDP, right? So.
that is one of the
Uh,
concern that I am whenever I am free, then only I will log in. Otherwise, if I on and then I am doing something other business, then it is not effectful. So
Yeah. So, yeah, yeah. So anyhow, like you please continue to attend the thing.
okay,
So
okay,
the final decision, like right now, I may not be able to say anything, but please attend.
okay. Thank you, sir.
Yeah, thank you. So I thank all those like who have submitted your assignments. So that were given on the first day.
So I have done, just I'm submitting it. Actually, I got late at night, so
Yeah,
I'll
yeah,
submit.
it's fine.
Yeah,
Please submit,
yeah,
ma'am.
yeah.
Yeah,
Thank you,
yeah,
sir.
yeah.
Hello. Yes. Good morning. Sorry. Actually, there was a power cut. Is it audible? Am I audible?
Yes, sir.
Yes, sir, you are audible. Yeah. So,
Thank you very much.
hello,
Thank you.
sir. Welcome. So, I've made you the presenter, sir. So, you can kindly begin, sir.
Yeah. Thank you. Thank you. Thank you very much. So, can you please allow me to share the screen?
Yeah, I think I already made you the presenter.
No, it's not enabled.
Okay, just a minute, sir. Yeah. Just a minute. Please wait for a few seconds. Okay. So, yeah, I've made you the presentation.
Yes. Yes. Thank you. Yes, I think now it is visible, right?
Yes, sir, visual.
So, is it visible? I am audible, right?
Yes, sir. Yes, sir.
Okay. Fine. Thank you. Yes.
Yes.
Yes. Yes. Okay. Good morning, all of you, and good morning, Professor Godfrey. Thank you very much for inviting me in this event to share my knowledge with all the participants. Thank you very much. So, yeah, good morning, all participants. So, it's an honor for me to be here with you and share my knowledge. Okay. So, today we are going to see this recurrent neural network. Okay? So, I think last 2 days you have already seen, last 2 days you have seen this neural network, this convolution neural network. Okay. So today we are going to see this recurrent neural network. This is another family of uh, deep learning. Okay, so we will be very slow. Okay, so and um, anytime during the lecture, if you have any comments or doubts, please interrupt me. Okay? So I want you be all be involved. Okay, so rather than just going through few. So whenever you have any doubts, you please raise your hand or interrupt me. We'll clarify those doubts. Okay. So today, actually, there are total 3 sessions I'll be covering. So first 2 sessions will be on theory, and third one will be on hands-on. Okay. So the theory sessions we'll see this the introductions, motivation of this recurrent neural network, and then the how actually it works. Okay, or what is the working principle of this RNN and its families, and then we are going to see next some applications what we have done, okay, in our labs. Okay, so if possible I will show you some examples, and this will be covered in the first 2 sessions, and in the third session, okay, so you will have one hands-on. Okay, so you will see how you may use this Python code to run this RNN in some basic applications, okay, like for text processing, and later you may use it for other applications wherever you want. Okay, so that's the agenda for today. So let's move forward. So before going to discuss, so I have actually shared these two information. This one is my website, parimol.iit.ac.in. Okay, so this is the homepage of our team. So all the projects, publications, and this some data sets, these are all available, okay, in this website. So if some of you are interested in working with some data sets, so you may download. Okay, so those are freely available, and several papers, projects are also there. If you are interested to work with me, or if your students are interested for internship, they can actually connect. And for connecting, so you have my email address here. So in the right side, this is actually partho@cs.iit.ac.in. So you can always drop a mail to me. So thank you. Let's see this one applications of this machine learning, deep learning these days. Right, so I think you have all seen several applications, okay, of deep learning, machine learning, because nowadays this deep learning, data science, machine learning, these are very buzzwords, right? So you see this, I show you one video, which is actually for autonomous driving vehicles. Okay, so here you see this cars are moving from one place to another place. Okay, so without any driver. Okay, this actually started in more than 10 years back from US DARPA, defense agency organizations, and they launched these competitions um, for these autonomous driving vehicles. So these cars are all equipped with these cameras and sensors, right? And then this you see that they are actually moving through the different environment. Okay, so it could be in a hill area. It could be, for example, this rural, urban. Okay, so see different places. Okay, so you have this problems like this autonomous driving. It's a big problem. There are actually several small sub problems are there. So, for example, these cars need to understand where is the road, where are the lines, and then it has to see this, for example, this pedestrians. Okay, so stopping, and then, for example, if it sees some signals, so it has to stop like this. Okay, so it will go through these different kinds of environment and different obstacles. Some problems are there. So you see this whenever it sees some pedestrians in front of it, it stops. Okay. Not only that, it actually works in this night vision when you do not have daylight. So there also it should function. So you see these kinds of problems actually people were trying to work using the simple machine learning algorithms, okay, before this deep learning. Okay, so 10 years, 12 years back, that time the deep learning was not so popular. So people started working with this support vector machine, these kinds of traditional machine learning algorithms. So you know this in traditional machine learning algorithms, how this work. So you have, let us consider that if it is a simple neural network, okay, so neural network actually um, it will take the data as features. Okay, so features means, for example, if I'm considering this autonomous driving vehicles, so the features for this problem. Okay, so like this sub problem, if I'm just saying this pedestrian detections. Okay, So let us consider this sub-problem like pedestrian detections. When there will be some persons, it has to stop. It has to stop. So it has to know that where is the pedestrian. So then it for this machine learning, so what kind of features it will extract? So in traditional machine learning approaches, they used to extract some features like histogram of gradients. Okay, fog. Okay, so that was very popular 12 years, 14 years back. Okay, so histogram of oriented gradients, and then you had shift, scale invariant feature transform, surf. Okay, these kinds of features, feature extraction technologies. So which actually extract the features from those image, and then they feed those features into some neural network of support vector machines. Okay, for understanding that what is the decision, whether is there any pedestrian or not. Okay, so if we are just going to do this using this way, neural network, support vector machines, random forest, these were actually extracting, these were considering input as features. Okay, so if you know this neural network, basic neural network, I think you have already studied. So just refresh. Okay, so this looks like a biological neurons, neuronal architectures where there are so many neurons are there which are connected each other. Okay, in a complex manner. Okay, in human brain. So this neural network was developed with the similar intention. Okay, intention means it will consider the input from some other neurons, and then it will process, and the information will be propagated to the next neuron. But the problem is that these connections are not so complicated. These are actually little straightforward, okay, in a simple way, so that human actually can design and they can use those things in their applications. So like it's a biological neuron, you have this neural network, you have this input layers. Okay, input, and then you have some several hidden layers, and which are actually connected. Hidden layers are connected to the previous layers. It could be input or it could be hidden, and then finally this hidden layers output are connected to the output layer, and you will get the results. Okay, so that's the neural network. Okay? So it could be, you can say, they're fully connected or multi-layer perceptrons. Okay, there are different names. The input there were actually were used input layer were considering these features initially. This shift, histogram of oriented gradient, those features were fed into this input layer initially. Now, if I'm going into more details of this neurons, okay, each neurons of this neural network. So you have this, what actually this neuron is doing. So like biological neuron, you have this you have dendrites and you have these axons. Dendrite actually considers this information from the other neuron, and it takes them to this center cell body, and where it process these informations are processed, and these are propagated to the other neurons through the axons. Okay, and then there will be some another neuron which actually get this information and process. Okay, so like this. So similar like your neural network configurations, here also you have several neurons. This neuron is considering the input from the previous, and then it processes and then propagates to the next neuron. This processing is very simple in our multi-layer perceptron. It actually does a simple weighted summations. Okay, so summation of the weighted inputs. Okay, so you have, for example, x0, x1, x2, xn. So what it does, it's actually making this summation of wi xi's. Okay, so that's the simple function, and then after that there are some activation functions like sigmoid or tanh, or for example you have this relu. These kinds of activation functions are there, which actually decide that whether the processed information will be propagated to the next neuron in what level. Okay, so shall we modify those features Okay, so for example, this total value will be, could vary from minus infinity to plus infinity. So shall I consider the positive value? Shall I consider the negative value? Or shall I consider those total value in a, I'll clip them. Okay, or shall I make it this total value in a, for example, the -1 to 1 range. Okay, so those kinds of activations are done by this activation functions. Okay, processor. So this AF is basically an activation function, and inside it's actually you have this processing. Okay. So in neural network, you have this process. This neurons are processing those information from the previous layers, and then how actually this learns. The learning is done by this back propagation. Okay, as you know, this you have basically several weights. Okay, that I was telling this inside. It's actually a summation of weighted inputs. Okay, so whatever inputs you have, this x1, x2, x2, whatever these inputs are there, these actually will be multiplied with a set of weights. Okay, so then how actually we will find those weights? So these weights are initially set with random numbers. Okay, so initialized with some values, and then later these are actually modified. Okay, all these weights are modified using some back propagation algorithm. Okay, so we'll see that from this weight matrix, whatever weight configuration you have considered initially, we'll see that whether we are getting good results or not. If the results are not correct, okay, if the results are not correct, then we will modify those weights. Okay, so we are adjusting those weights so that you can actually get the results better. Fine. So this adjustment of these weights are done from this back side. From if you are getting from input to first layer, second layer, and output. So this adjustment of these weights are done from this back side. So if there are some errors, these weights in this from this last layer to this output layer, this will be first modified, and then accordingly after that, whatever will be the results, this will actually propagate to the previous layers. Okay, so like this errors will be adjusted. Okay, fine. So that's actually this neural network, and then as I was saying, this is actually a multi-layer perceptron. It processes these inputs, and then you have several layers, and then it actually gets the output layer. So what is the difference with this neural network and this convolution neural network? Convolution network actually, in the convolution neural network, it actually takes the input as the image. Okay, so then how actually this neural network multi-layer perceptron works? So in this convolution neural network, you have basically this feature extraction and recognition both. Okay, these both are actually combined. Okay, one after another. Okay, so yes, so when you have this actually this convolution neural network, so in a convolution neural network deep learning, there are actually two parts. One is actually feature engineering, another is your classification. This classification part is same. Okay, that is actually this multi-layer perceptron. This feature engineering is actually done using this convolution. Convolution, as you know, this is actually 3x3 matrix or 5x5 matrix something. Okay, which will use some filters, okay, kernel filters, which that will be convolved with the image, input image. That will convolve with the input image and extract some features. For example, this you might have seen this edge extractions, or this line horizontal line extraction, vertical line extraction. Those are done actually using this convolutions operations. So in this deep learning, in this convolution neural network, you have this feature engineering, this feature extractions are done using these convolution operations, and then after that you have this simple multi-layer perceptrons, okay, which uses those features generated, developed, extracted by this convolution engineering part, and then it uses this recognitions. So you have actually this, for example, one example is there. So you have this car. So we extract, we use some convolution, different convolution kernels will be there. So you can use some convolutions and you will have several features. Okay. So once you can have actually several layers. Several layers will be there, which use one after another, and then you will extract finally the features. So these are the features. Okay. And then these features you make it in a vector form. You flatten all these values and you make it in a vector level, and then you apply them in a neural network, multi-layer perceptrons, and get the results. Fine. And there are actually many CNN architectures are present. Okay, at now. Okay, so every day actually several CNN architectures are coming, new several architectures are coming. So some of these popular architectures are that AlexNet, then you have this this VGGNet, and then ResNet. Okay, several architectures are there. So these are all available. Okay, so you just need to apply this architecture, and then they are actually standard forms. Okay, that how many convolutions, how many max pooling, okay, real active, what are the activation factors. There are some standard forms. So if you just proceed with those architectures, so this then you will get the results. So this will be done with an image form. Okay, so in the image form, so any doubts here? So I hope these are all clear. Okay, so this what is actually this neural network, CNN, these are all clear, right? Fine. So now let's move that. Okay, so then in this neural network, you have seen this.
Sorry, sir, interrupt you. Good morning, sir.
Yes, yes.
Sir, I have one question, sir.
Yes, yes.
CNN is using so many filters inside this. So
Yes.
can I use any other filter before entering the image into the CNN so that I can improve the accuracy or efficiency?
Yes, yes, yes.
Any significant for that, or no need to improve the image enhancement, or no any other? What I mean to say, sir, because CNN already using some filters inside this, so can I do even before entering the image some enhancement of the image so that I can improve the accuracy? That is my question.
Okay, so you want some image enhancement before you apply this deep learning?
Yes, sir.
Yeah, see, where actually we are using this deep learning, CNN. So in CNN, this convolution is done by some filters, right? It could be 3x3 filter, 5x5 filter, 7x7 filters, whatever. So these filters are not designed by you. You are not designing these filters. Okay? So these filters are designed by the machine. So first, for example, this filter, let's consider it's an example of 3x3, okay, and this numbers. So what will be the filter, these elements? For example, if you want to consider this, you want to extract the horizontal line edges, okay, edge extraction from the image. So what kind of filters you will be using? So for example, it could be 1, 1, 1, 0, 0, 0, -1, -1, -1. Okay, so something that actually you are designing and you are controlling throughout the image, right? But when actually we will be using this machine for convolutions, so in this 3x3 matrix, you do not fill up any values. So those values, those numbers will be filled up by this neural network, by this neural network machines, okay, by the backpropagation algorithm. So you start with something called something like 0, 0, 0, okay, or all 1, 1, 1. So this 3x3 will be all 1, 1, 1. And then through backpropagation algorithm, this machine neural network will understand that, okay, how these values should be changed. So whether it requires this 0 to 1 or 1 to 0, so this will be designed by the machine according to the application. Okay, if your application is always like this horizontal features, okay, then it will design gradually this 1 1 1 0 0 0 minus 1 1. If your application is like all are having this vertical edges, then your filter will be designed by this and the vertical way. This is 0, then you will sorry 1 0 minus 1 1 0 minus 1 1 0 minus 1. So these numbers 1 0 0 0 1 1, it could be 1, it could be 0.5, it could be 0.6. Okay, so the 3 cross 3 could be 0 0.7, 0 0.9, it could be 1.3, anything, any number. These numbers are generated by the backpropagation algorithm. Okay, so it starts randomly, starts with random value like 2 3 4, any number. So you will start 2 3 4 5 6 7 8 9 10 random, let's consider, and then it will see using these convolutions that what are the features it got. Okay, and then it will check that okay, this feature is important for this classification or not. If it is good for classification, then this is the best feature. If it is not good, means you are getting some error, then using this backpropagation, those features, those values of the kernel will be modified. So from 2, it will be modified like 2.5, some 10, it will be modified like 9.5. Okay, so this filter is modified internally by this backpropagation algorithm. You don't, so these are like weights. Okay, this this 3 cross 3, it's like weights. These weights are modified according to backpropagation algorithm. So you do not need to do any pre-processing. So these are done through this machine. Yes.
Good morning, sir. Good morning, sir. Sir, actually, the way you said initially, we have taken some filters like 3 cross 3 or 5 cross 5 or 7 cross 7, whatever it may be, and there will be like 32 filters or 35 filters, whatever it may be, we can take. So how randomly it is? Who chooses these random values? The way you said, it will be initially chosen with random value. Then when there will be back propagation,
you have to choose. User has to choose the random numbers. Okay, so you just give a random numbers. Okay, it's actually when you will decide this kernel's convolution filter, you choose some random numbers. Okay, so it could be
so
you
for
means
all the
you will make a random function generator, and random function generator will pick up some numbers and it will fix. Okay, and those numbers will be modified.
sir, if we randomly choose anything, for an example, let's see, I do not know what the exact values to be chosen, and I have randomly chosen lot of value. It has been away from the actual value. The difference is lot more. So in that case, the training will not it be exhausted, and it will demand lot of time. If my initial
Yes, it will take time. It will take time, of course. If this values are different, see, there are actually techniques for this optimizations, all those techniques, which actually takes care of how you can move to this converts to the solution, this solution very fast. Okay, so there are techniques like optimization. There are actually several rules, laws, optimization functions like ADAM. Okay, then you have this RMS prop. Okay, there are several algorithms are there which actually helps you to reach to this base solutions from whatever. Okay, you start, it will try to converge faster. But this is the problem of convolution neural network. That's why it takes a lot of time, and you cannot run this in CPU. Okay, this is the main drawback. That's why we need GPUs, because there are so many filters. Okay, so you are seeing 3 cross 3, 32. Okay, 3 cross 3 filters and 32 filters like this. So that means it will be 9 into 32. Okay, so that's a huge number, and then it will be in the several layers. So all these numbers will be fixed according to this backpropagation algorithm. So that will take a lot of time. So there are actually, if you consider this convolution neural network, deep learning, and the CNN, there are millions of parameters, millions of weights, Ws. These weights are all adjusted using this backpropagation algorithm. Okay, so by running again and again iteratively. Okay, this will take time. That's why we require GPUs. With CPUs, it is not possible. It will take a lot of time in GPUs. So that's why if you start processing, maybe you will get results after 2 days or 3 days, even in the GPUs. Is it okay, sir?
Yes, sir. Thank you, sir. Thank you, sir. Yes, sir. Thank you.
Yeah, any other comments, questions? Fine. Okay, let's move. Yes, so what we have seen this in this CNN, that it actually considers some input image, and then you have the labels, okay, and then it will try to see this, okay, from input image to output, it will try to fix the parameters and it will get the results, okay. So that is called training. This fixing those parameters are called training. So when you get the values of this W's, so you can use those W's in your testing data. Okay, so when you have, this, these are the W's configuration, so you just multiply with these W's with these inputs and you get to the next layers and layers. Okay, like this you will get the results. So here you see this, when you consider this simple input and output, and then we are fixing these parameters, so we are not considering any sequence. Okay, so for example, if I'm just saying that like this in this image example, for example, this input feature, so like x1, the input sequence x1, x2 and x3. Okay, so these three variables, okay, these three input, or it could be a features. These three doesn't matter whether you consider in a x1, x2, x3, or x2, x1, x3, or x3, x1, x2. Whatever sequence you make, okay, the order doesn't matter, right? So you can give the first input as the last layers, and then the last input as the first layers, first input features, and then you can get the result. There is no importance of ordering, okay, but it actually sometimes this order is important, okay. So whenever you have some ordering of those input feature, then actually this CNN or this simple traditional machine learning will not work. Okay, so you require some different kinds of machine learning algorithm. So for example, here you see there actually if you have these kinds of positions, okay, so this these are all insects are in different random moving, and you want to find the shape. Okay, so you can actually give this number, means this locations anytime, and then you can understand that that okay, there's no order. Okay, so all these elements can be placed in any place of this input. But when actually you will see that this kind of sequence is there, so if one actually you are missing, actually starts this order is very important when we consider some time series data. Okay, so time series data, for example, if I'm saying what in regressions, I think you have this forecast. So weather forecast or some regression, which actually depending on the previous data also. So like talking share market last few days, what are the values, how actually it is changing, what is the trend. Okay, I need to understand the trend or pattern. Okay, so the temporal patterns I need to understand. There actually the CNN or neural network, traditional simple neural network or support vector machine, these will not work. So there actually it requires some sequential machine learning algorithms. Sequence machine learning algorithms in traditional way, there is actually hidden Markov model. Okay, hidden Markov model used to take care of those sequence pattern recognitions. After this neural network, people started working that how you can use this deep learning. Okay, this deep learning model, this different layers, how you may use those deep models for time series data. Okay, so let us consider this another example, a very good example. So, for example, if you see this two words, okay, if I'm saying that sentiment analysis, for example, that people place comments, okay, on the movies or the products, okay, in the social media website, that okay, this movie is good or the product is not bad, okay, so something like this, okay, it is bad. Okay, so when I'm saying this movie is good, that's positive. The movie is bad, negative. So this you can actually use using your neural network model also, that okay, this movie is good. This means these are all means words are considered as a single individual element, and you can get the results. Okay, because here it's a good word is there and it's a bad word. So good is positive, bad is negative. But others actually they do not have any much information. But when we consider that this movie is not good, this sentence, then what will happen? So you are considering this. This is a one features. Movie is another feature. Is another feature. Not is another feature. Good is another feature. Okay. So if you have these kinds of information, and then if you are considering this bag of words, then good word is there. Then so it will also consider as a positive. Okay, because this change of this pattern, change of these words in a sequence, actually it matters a lot. Okay, how actually you are using the context. Okay, so this, for example, this previous word is not good. That actually it means negative. So that we need to understand. So this is not possible using this CNN architectures. So there we have this recurrent neural network architectures. So which actually understand this temporal information, how these words are coming. Okay, what is the sequence? What is the order of those in the sentence? And these actually are considered, okay, to have the final results. Okay, so we'll see that in many places, okay, everywhere almost, we have the importance of ordering. Without order, actually, it doesn't mean, okay, many places. For example, if you consider this text recognitions, natural language processing, okay, text recognition, for example, if it is word recognitions, okay, it is okay. But word sentence, if you want to consider, then actually you will have this ordering matters. Okay, how this sentence is constituted with this several words. What is the sequence of this words? Then you will have the video. Video is actually a set of frames. Frames you can process using CNN. But when actually you will have a ordering of these frames, then if you change the orders randomly, it doesn't, sometimes it will not make any sense. Okay, so to have this meaning, so we need to process them in a sequential manner. Similarly in audio, okay, so if I'm just talking something, and then if you change this some of these features in the beginning, so it will not work. But in CNN or this traditional machine learning algorithm, this will work. So when we want to consider the context, that what is the previous information, what is the previous in next to previous, okay, so like this, so there actually it matters a lot. It will be in a time series data, finance, in an industry, every. Okay, so you have the stock exchange data, weather forecast. So, for example, this, if you want to go for this health checkup, okay, means what was your ECG rate yesterday? Okay, so how actually it matters today? So there are some context. Okay, history. Okay, so we have to consider that history information also to predict today or tomorrow. Okay, so that's why this sequence is there everywhere. So, for example, we can just saying this one example that we want to train a generative model of natural language. Okay, natural language, like you have a set of words like stack more, stack overflow, okay, stack more layers, stack more things. Okay, so if you want to generate a sentence with these kinds of words, so what you will do, you will actually have a it's actually a Bayesian models. Okay, so you have this probability of all these different words where this it comes that, okay, probability of x0 when this it is given this previous information. Okay, x1 given x0, x2 given x0 and x1. So what is the previous information, previous piece of the sentence, and what is the previous to previous piece of the information? Okay, if you know this stack, then you can actually go for the stack mode or stack overflow. Okay, if you know this stack overflow, then only you will have this other models. Okay, other words possible. If you see this stack mode, then stack mode and ease will not appear. Okay, so that's why this sequence is very important. So what kinds of words actually you are choosing, and accordingly it will change the total series, okay, of the data. So this actually is useful everywhere. So for example, chatbots, question answering. Okay, so how actually you are making this question answering, machine translations. If you say some English words and then it will be translated into Sanskrit, speech recognition, everywhere actually you will be using this sequence. Oh, okay, this recurrent neural network, hidden Markov model, all this machine learning paradigm. Okay. Now how it works. Can we do it using this multi-layer perceptron? Is it possible? Okay, you think of it. Is it possible that can we do it using multi-layer perceptron? Okay, how come? Yes, Anirudh said yes. How come we can use? Can you please unmute your mic and you please speak?
So we define the number of units, number of input units, the number of hidden layers accordingly, and the activation functions, the desired activation functions, so that we can get the output instead of going for a binary output. We can also go for assume considering any activation function, which is a nonlinear activation function. Maybe we can obtain this.
Yeah, that is good. That is good that you are getting some answers from this a set of
So can I say something, sir?
vectors, okay, features. You are getting some output. Then how actually you are maintaining that order? Okay, so this how this previous information you are considering for the next output. So you
Sir,
see
can I say
everywhere.
something? Excuse me,
Yes.
sir. Can I say something?
Yes, of course.
So CNN basically a regularized version of the multi-layer perceptron. So multi-layer perceptron is possible when usually using while we are using a fully connected network. So that is a each neuron in one neuron is connected to the all neurons. In the next layer, that would be the hidden layer, of course. So the fully connecting
Can you
of
please
this
be little
network.
louder? Yes. Can you please be little louder? Yeah, sorry.
Yes, sir. Yes, sir.
Mhm.
So I'm repeating once again. So CNN basically use a regularized version of the multi-layer perceptron, and
Yes.
as we know, the multi-layer perceptrons means we are talking about the fully connected network. So that is each layer in one layer of the our neural network is connected to the all neurons. So in that would be the next layer. That would be definitely would be the hidden layers. So the fully connecting, we are talking about the fully connected neural network. So these kind of networks require the multi-layer perceptron. So that's why we can say CNN support the multi-layer perceptron.
No, CNN supports multi-layer perceptron. Of course, CNN. There's CNN in includes multi-layer perceptron. See,
Yes, of course,
multi-layer perceptron is the backbone, okay, of the CNN.
yes, sir.
Okay, CNN is the multi-layer perceptron here in your CNN. Okay, deep learning, all these architecture, multi-layer perceptrons will be there. Okay, so multi-layer perceptron says that you have several features you will are convolving and then you are getting the results. Okay, in CNN. Okay, the convolution is done by some filters, but the process is this weight. Okay, weight initialization, back propagation. These are all the general principle of multi-layer perceptron.
So, as Anuja just said,
Now,
so
my
as shown in
question
here,
is okay, let me repeat my question that what we are doing. So, for example, in this previous example, like you see this, if I want to have a sentence, okay, stack over stack more chains. Okay, so here what I see that so let me find out one word stack. The next word I'm considering according to the word I have picked up, okay, the earlier. So if I have picked up stack, then the next word will be one of the stack more or stack over. If I choose stack more, then the next word will be stack more layers or stack more chairs. Stack overflow is or something, okay. So you see that then the third, the three words are coming according to the two words previous history, okay, what we have got received. Okay, so if we receive stack more, then these are the outcomes. Okay, so how actually we can use this kind of generations, okay, sentence generations, like what output we are receiving before that output is the input in here.
so I would like to add here.
Yes,
So
yes, yes.
yeah, so as shown, like definitely we can use multi-layer perceptron here.
How?
So whatever knowledge we are getting from the, like we are entering words or sequence of words, whatever we are having in a specific sentence, then we are, if it's like a first word in the first layer, then it's giving weight to that word that is coming as a weight, and like that is like a x naught is like a input which is going to multi-layer, and then all weightage are set by multi-layer perceptron. Then that word along with weight is going to next multi-layer perceptron, as shown in your this diagram. Xi minus 1 is input, which is like previous words whatever, I will not say weight, it is like probability of coming that word along with any other word in a sequence. That probability is going as an input in my next layer, and then again that process is repeating again and again up to my sentence length. Is it so?
Yes, 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 absolutely, you are right. So what we are doing, so we have a multi-layer perceptron. We give a word, for example, we start with some stack, okay, this example stack. And this multi-layer perceptron, for example, in this multi-layer perceptrons, you have two hidden nodes, okay, one hidden layer with two hidden nodes, and it actually gives you some predictions, okay, the probability of two words. It could be more or it could be overflow. Okay, this multi-layer perceptron, this actually gives you the probability of two words. If it is input is stack, it could generate more, it could generate or overflow, right? So yes, overflow, stack more or overflow. Now, if whatever more or word overflow I get, and then this more I consider here in this another multi-layer perceptron. And this more, if we use, then more actually will be considered in this multi-layer perceptron. It will give you another probability for the next word. So that means the output of the multi-layer perceptron is considered as input to a new another multi-layer perceptron, and it is actually giving you the another word, okay, possibilities. So what we are saying that you are giving a word stack, okay, in a multi-layer perceptron. You have some hidden nodes, hidden layers, and finally you get the output. Okay, output could be, for example, one of 3-4 words. Okay, probabilities. Okay, so it could be more, it could be overflow or something. Then whatever you are getting, this stack or more, that word will come, okay, as input to that multi-layer perceptron. You apply this word again to this multi-layer perceptron and you get the output. Okay, so you have a neural network. Okay, you have a multi-layer perceptron. With multi-layer perceptron, it's like here, like this. Okay, here, like this. Okay, so you apply stack, you will get more. You apply more, you will get rise or risk books. Okay, so according whatever you give input, you get the output. So stack, if you give input, you will receive more. So that means this output needs to be connected to the input. Have you got it? How we will do it, I will tell you. Okay, just learn the concepts, what we are trying to do. Is it clear?
Yes, sir.
So clear.
Okay, so if we are using, for example, what we are doing now, if you see here, in this example, we give stack, we receive more or overflow. And then according to stack or more, after that we get stack more layers. Okay, so then layers actually coming, either if previously it was more, and then previously it was stack. So these layers actually depending on this previous two words, stack and more and stack. Okay, so that's why this is the probability of sequence. Okay, this actually you decompose into this each of these words. Okay, so this okay, so this is actually the initial probability, then the next word's probability, then next to next word probability. So this third one, this layers will be of given this previous two informations, x0 and x1. But if you are using a simple one layers like this, only a simple one, then you are actually considering one input and you are getting the output, and that output is considered as input. Okay, but then previous information, that x0, that the previous, this first one, the stack, this was you are not considering anywhere, right? So then what we'll see, that information also we need to fit somewhere. So maybe in this multi-layer perceptrons, we should have another input which will give you the some probability of the previous. Okay, like init. Okay, so initially we start with some, for example, you can say that start. Okay, so initially it will be 0, and then if we start, and then what this influence will be there in the second example. So in this example, let's consider that the input is more, and then you are getting overflow, and then stack information is missing. So stack information, this will be considered from somewhere. Okay, so from this previous information, so there actually to have this stack. So this influence we consider by some informations. Okay, so whatever this age neurons or output is you are receiving in the previous, that information we connect. Okay, so this will be a simple connector. Okay, where you have a word and it will give you this a possible next word. Okay, and it will also consider the previous informations. Okay, so we'll see. Okay, so what we have seen, this multi-layer perceptron is possible. So we actually this recurrent neural network will be done using this neural network or multi-layer perceptron. So okay, only. So what we are doing, we have this neural network architecture So each words will be given to this neural network. It will be the output will be the next word. Okay, so that's actually simple. Okay, so you can do it anything. So if you give stack, then you will get more. If you give more, you will get layers. If you give layers, then you will get in some place name. Okay, so something like this. So then where the previous to previous information is there, you are just considering a single piece of what stack mode overflow. Then the stack information, where the stack information, this word will be given. So this information should be given in some form. Okay, so that's why we need a sequence. Okay, so whatever we get the results, those information will be also be given as input to the next multilayer person, so that the previous whenever we generate this, if we give this mode, it will generate overflow. Then the stack informations or other information, this will also give some influence. Do you follow what we want to do? Is it okay? Hello? Yeah, we'll see several more examples. Okay, don't worry. So we'll see that classify a restaurant review from Yelp or movie review from IMDb or as a positive or negative. Okay, so if you want to make a review, okay, so input is multiple words, one or more sentence. Output is positive or negative classification that I was telling. So the food was really good. The chicken crossed the road because it was so you have actually given several set of sentence. Okay, so in these sentences you are having actually different number of words. So for example, here you are having 5 words. Here you are having 1, 2, 3, 4, 5, 7, 8 words. Okay, and this each word in this sentence is actually depending on the previous words. How actually this language is constructed and what is the meaning finally, whether it is a positive or whether it is a negative. So this sequence and the sentiments, these are actually depending on this temporal order, and then we want to go for sentiment classifications. Okay. So what we will do here, so if we want to go for the food was really good, so what we will do, like a neural network, we have a neural network, we give this the first word. Okay, so the and then this the will generate some food, let's consider. Okay, and then food we give into this multi-layer perceptron, and we get the sentence like was, and then that was will be considered here, and then we are getting a multi-layer perceptrons and we get some results. Okay, so like this result, the previous results are also fit into this multi-layer perceptrons, and finally at the last layers we get the output, that whether it is a positive or negative. Okay, so we'll see that it's how actually we'll do. So these outputs we do not consider. Okay, so this so there are actually many applications. You will see, given an image, produce a sentence describing its concept. So that's actually a popular applications of in image processing, that you are given an image, you can use this CNN for classifications. Okay, so whether there is a dog is there or not, or what you see, what objects are there, but you want to find out some set of words. Okay, some set of words which actually make a sense. Okay, you consider you want to find a sentence. So let us consider that, for example, in Facebook you put a photo, a picture, and then Facebook itself, it actually tells you that what will be the caption. Okay, so for example, you are in front of Taj Mahal, something. Okay, so I have taken the photo in front of Taj Mahal. So this sentence will be constructed immediately once you upload the image. So you do not need to write anything. The machine will generate. How actually it will generate the sentence. Okay, so the meaning of a sentence of this image. Okay, so you think that, okay, so what first he has to understand that what are the things, objects are there. So it will actually apply some CNN, okay, some objects, what are the, for example, dogs, birds, whatever is there. So it will extract some objects, and from those objects, it will find out, use this objects means it will find out some words. Okay, so for example, it will say that, okay, dog, bed, and something is not visible, fully is visible, not visible. So this information will be considered in this sequence because you want to generate a sentence. So these sentences will be these words, set of words will be generated, used in a multi-layer perceptron one by one. So you will have this dog, you will say the dog, and then you will have this bed, okay, and then actually you can find out a sequence of sentence. Okay, person is writing about himself. So these are actually already there in a data set. If you are interested, you can actually download those data sets and you can start working. Okay, so you see this, these are also some examples like in RNN. Okay, this machine learning, deep learning model, this actually can generate music. This can generate sound. This can generate a story. Okay, everything, paper. This can generate also your research papers. Okay, so this is actually happen. Okay, so if you train this RNN, okay, that okay, this because RNN manuscript what is given, you have this abstract, introduction, methodology, something. Okay, and these are trained with many papers, many works, and then this machine actually will generate a abstract, an introduction, a paper. Okay, so based on the in context information. So it actually generates, for example, you give a set of words of the Shakespeare, okay, books, and then if it trains that, okay, it understands that how actually the novel is written. Okay, so what are the words they have chosen and how actually it is written. So based on this, if you give some words, then it will generate a sentence or paragraph. Okay, so this that's why this recurrent neural network is very very important, right? And it's very effective in our day-to-day applications. So when we are saying this single image is a neural network, it's actually input and output. Single to multiple, it's an image capturing. Okay, so you actually give some features and it will generate some set of words. Okay, and then multiple to single, you are giving some multiple inputs and then it will generate a sentiment analysis, whether positive or negative, and multiple to multiple, it's a translations. Okay, we'll discuss, okay, all this one by one. So let me go to this concept a little. Okay, so as you have understood that, okay, what we are going to do. Okay, so I'll come back, okay, with those examples again, okay, in the second slot. Okay, so and then we'll show you several other examples also, applications from our lab. So what first we let us understand that how actually this RNN works. That you have understood this, it actually considers this multi-layer perceptrons, neural network, okay, where you have input is x1 features. Okay, it could be a, for example, you have a set of features, 3 features or 4 features. Okay, x1, x2, x3, x4 or something. Okay, so here x means x1, x2, x3, x4 or whatever, if it is 3 x1, x2, x3. Okay, and then it produces results. Okay, so results of y. Okay, results means you have this output. So if you are considering this is a multi-layer perceptron, so neural network, you are getting results, this output. Okay, so you have some hidden layers, you get the results. Okay, hidden layers, it makes some weight adjustment and you get the results. And those informations, hidden informations, what actually it understood from the input, okay, the pattern, that is again fit into the multi-layer perceptron. Okay, so in multi-layer perceptron, actually you have 2 sets of input. In usual traditional multi-layer perceptron, you have only a single set of input, that is x1, x2, x3. Okay, or whatever. If you are having thousands of features, it is x1 to x1000. In recurrent neural network, those features are there along with some another set of input. That set is the values of the previous multilayer perceptrons or the output of the previous multilayer perceptron. Okay, so you have this input multilayer perceptron, you have this input and output, and that output will be considered as input into the multilayer perceptron. So in recurrent neural network, you have two sets of input. One is x1, x2 to x1000. This is a traditional way of features. Another is the output of the previous results. Okay, so whatever results you receive, that will be given. Then you can say, sir, initially we didn't have any results, any value output. Then how can we can fix these values of this another set? What will be the values? Yeah, that will be, you can say that is a that you can ignore. Okay, that could be considered as zeros initially. Okay, so you have this x, another is like your previous input, like age. Let us consider that it is an age. Okay, and this age will be initially as zeros. And then after first step, you are getting some results. So that means you will get this outcome O1, O2, O3. Okay, so that information will come here. And then you get the results. And these results will come next time as this age. Okay, so everywhere, every time, the outcome is also will also appear along with the input. So there actually you are maintaining the order of the inputs. Okay, so you are coming with this first word, second word. Second word is actually depending on the first. You get some results. You apply input that results along with the second word. Okay, this is the second word. You get the results. Okay, like this actually this recurrent neural network one. So you have this input features, recurrent neural network, and predicts output at some time steps. Okay, so let us going into more details. Okay, let's go into detail or detail how this multi-layer perceptron inside actually it works. So you have a set of features x, and these functions. There actually you have this functions. Okay, if you are considering only this if functions like multi-layer perceptrons, what was the features? What was the functions? Function was simply wx, right? If you remember, in multi-layer perceptron, the features, okay, the inside, okay, I'm just I told you. Yes, yeah. This feature is actually summation of wx. Okay, so whatever x are given, you multiply with the w's. Okay, that is the f function, and it actually makes after activation you get the result, and it is connect. You are getting the results. Okay. Here, as I said in the previous slide, your input will be two sets. One is the input x, and the previous another set is ht minus 1. Okay, so what is the outcome or the some other values from the previous state? Okay, so you have a set of features, you get the results. Either you can consider that results or some outcome from this activation function. Okay, after this f, whatever you receive, that actually comes as this ht minus 1. Then is the this ht that will be appearing as the along with your feature. Okay, so this functions, this input of this multilayer perceptron is xt plus ht minus 1. ht minus 1 is your input from the previous state. Okay. So let's see it. I'll explain. Okay, so you have this ht minus 1 and xt comes, both are considered in this multilayer perceptrons. Okay, how we are going to do it? Okay, so if you see now this example, so you have this neuron. Okay, so initially you have this x1. Okay, and h1 was this other set was 0. Okay, and then let us consider only you have this single feature x1 only, x size. Okay, only one. You can, if you consider these 5 features, then you will have x1, x2, x3, x4, x5, x1, x2, x3, x4, x5. Okay, everywhere you have this 5. Let us consider that you are only having input, single input. Okay, so you consider this x1 and this another set that is hidden, previous inform, there is no previous, so it will be 0, and then you have this multilayer perceptron, you get some outcome, and this from outcome you make some predictions. Okay, y out. Okay, this h, okay, h is your basically summation weight wxi plus b. Okay, so that's actually in this multilayer perceptrons what you do. Okay, so and then you can make some activation function also. In a neural network you are using sigmoid functions, tanh or ReLU, all this. Okay. So here you can also use some HDS tanh. So you can consider as a tanh functions or sigmoid function, anything. Okay, so you have this x1, this h0. So what will be the functions? So w1 x1 plus w2 h0, okay, plus b. Okay, so this is the total input, and then you make some sigmoid functions or tanh functions or whatever, and you get the final this outcome h1, and then from this h1 you make predictions. Okay, either y1 or y2. C1 is the loss functions. Okay, so what is the error, and then based on this actually you modify. So y1, y2, these are the results, and this h1, this activations after this is tanh functions or sigmoid functions, whatever it is. So this h1 will come again in this set, and this x1, this is the next word. Okay, so initially it was, for example, the word is that was you start stack, and then it will be stack mode. Okay, so it will be mode only, and then this stack with some zeros, whatever values you paid, it will be mode and this h values, and you get this h2, and this h2 comes, and this x3 is here. What will be the x3? It will be overflow. Okay, or something. So whatever this third word you are giving, and then it will generate the h. So like this output of the previous state multi-layer perceptrons. Okay, the same multi-layer perceptron, you are using it in the next layer. Okay, so this is simple recurrent neural network. Is this correct? This architecture, do you follow it? This is the working principle of recurrent neural network. Very basic recurrent neural network. You have to understand it. Otherwise, you cannot move. Okay. Is it okay for all of you? Shall I repeat? If I do not consider the second and third one, only this first one, can you consider that is a multi-layer perceptrons? Only the first part.
Yes, sir.
Everyone, can you understand this is a multi-layer perceptrons? Simple. Okay,
Yes,
x1,
sir.
you have this x1, let's consider there is nothing, it is 0. Okay, so x1, what you are doing, you are basically making multiplying wx plus b. Okay, bias, it's basically this weighted input, and then what you consider, you use some sigmoid or some activation functions, like it could be sigmoid functions or activation functions, and then you have this h1. Okay, that is the next. Okay, h1, and from this h1 you make it in label, either it would be yes level or no level, which category it is. Okay, that's actually this. From this output you can make it a classifications. It could be y1, it's a car, or it's a animal. Okay, so that's actually simple neural network or CNN. Okay, that does. Okay, and then if you do not get proper labels, if there are some means, if it is actually a human and you are predicting as a car, then that is a error. Okay, so what is the probability, and then accordingly you modify. Okay, those weights are modified. This is the very basic. This first layer, first simple block is a neural network, simple. Okay, so you have to understand this first block, and this first block, after this first block, we just consider this output h1, we just pick up, and then we place it as another set. Okay, that was actually blank in the initially, it was 0 or some random values, and then we keep x2, this input vectors, the second set of words, second word, and then along with the previous information. Okay, so you see that this previous information is not the x1, okay, the previous node, but it is just some processed output. So there will be some influence. Okay, there will be influence of x1. So x1 influence is coming as a processed one. You are not using this x1. Here in this third block, you are not using directly x2, but what you are using, you are using the influence of x1, x2 both here, right? Because here you are not using x2, you are not using the second word, stack overflow. You are not using. You are using processed information of overflow, which is processed over, which is considering processed information of stack. Okay, so both informations are coming, and they influence together to generate the third word or fourth word. That's why there is the ordering. Okay, this ordering is maintained like this, in this way. Is it okay? All of you, anyone having any problem? I can repeat everything. Okay, so whatever we discuss, I can repeat the full things. Is it okay?
Yes, sir.
Yes, sir.
Yeah, repeat loss. Okay, loss functions. Okay, loss functions. So, for example, if you are using CNN, did you have any hands-on CNN? So, okay, so if you had hands-on, then you should have understood this loss function. So, loss function, what is loss function? Loss function is, for example, in it could be mean squared error, it could be cross entropy error. Okay, cross entropy error, mean squared error. Have you studied? Have you studied this mean squared error, this cross entropy error? Okay, so what are these? So cross entropy error, for example, you are actually having, for example, let's consider 2+ problem. Okay, so 2+ problem, you have a fruit. Okay, so you want to classify it is as a apple or mango. Okay, so you want to classify it as a apple and mango. You have an input image of apple. Okay, and then you say that the output, okay, output is probability that it is of apple is 0.67 or 0.8. Okay, so you are considering a probability that is y1, that's actually y1 will be, for example, you are giving a level also you can give, and this level is say 0.67, means you actually say that it's more than 0.5, so it will be considered as apple. Okay, so it will be either 1 or 0. So then according to this probability, so you can actually, you want to make it better, 0.9, you want to move it 0.9 or 0.95. So then this loss function is actually this cross entropy error. Also you have some functions like minus y I log I and minus 1 minus I log 1 minus y. Okay, so this is the cross entropy error. If you are considering this mean squared error, then you have this actual outcome and then what you are predicting, so you find out the difference. Okay, so that difference you make the square term and make a summations. That is the difference, means how far actually you are from the prediction, the actual value. So your actual value is apple, it is of 1. Okay, and you're predicting it as apple with 0.67 or 0.8. Okay, so that means the error is 0.2. Okay, so that is the error. So this loss, this 0.2 factors will come in the back propagation and modify these weights such that you will get, the next time you should get always 1. Okay, something is always, if you are giving this image, you will get always this apple always with the 1 probability. Okay, so that's what it is, a loss function. Loss function is whatever is the actual outcome and what are you predicting. Okay, if it is apple and you are predicting mango, okay, or with a probability 0.5 or 0.6, and what is the difference? This difference is the loss. Means this is the difference. Okay, so this is the gap between your actual outcome and your learning methods. So this loss will be this loss has to be learned. Okay, so this loss will be learned using this backpropagation algorithm. So C1 will be, it will be learned in a backpropagation algorithm. Okay, in this idea. Okay, so that's why this loss function actually takes yi, means this is the output what you are predicting, and this is ground, gt is the ground. Okay, so the ground truth is, for example, it is apple. You then, if you are saying that you are predicting it's an apple, then there is no error. If you are saying it's a mango, then there will be error, and what is the problem? So this is the loss function. This has to be considered. Is it okay? This loss functions. Okay. So you, if you want to more, you want to study more, so you see this mean square, this in multi-layer perceptrons. You have CNN. You have this mean squared error. Then you have this cross entropy error. Okay, so these are the some loss functions. There are several other loss functions are also there. So the concept is how far you are predicting. What is you are predicting, and how far this prediction is away from this actual value. So you make the difference and you consider it. Fine. So this is the loss functions, and yi is the function of this this h. Okay, and you have this ht is this tan h. It is a sigmoid function of this weighted matrix. See, now you see this w, you can write it like this: w ht or xt minus 1 x. So here w means, see, when we are considering x1 and you have this initially 0 and then x2 and this h1, so you have this like in multi-layer perceptrons, what you are doing, you consider w's, right? W into x2 plus w into h1. Okay, so w, you are considering multiplication of this w, it's a weighted matrix, so you have to multiply with some weights, and these weights will be adjusted using backpropagation algorithm. So that's why you have this w's, w into x and w into xt minus 1. So you have to have w into this and w into this set of values, and this will be you have this whatever value you come get w weighted summations, and then after that you make some activation functions, and you receive the y. Okay, y could be function of h, means it is actually, you can say that this is a if it is a regression, it will be just that the value, okay, actual value. If it's a classification, if the total value is more than 0.5, this is a class A. If it's a less than 0.5, it is class B. Okay, so this is the level. Y is the level. Okay. Now, once we understand this, you have this here, this loss functions. Okay, this values, these functions. Here, this function, this means whatever functions we are using from h1 to y1. Okay, or these functions, whatever we are using, this x1 set and h1, this h0 set to this h1. So this weight matrix and everything, these are all same. Okay, these are shared in every blocks. Whatever functions we are using in this block, these are all used in the same way in every block. Okay, so whatever weight matrix we are using in this block, this will be same here. Whatever function we are using here, this will be same here. Whatever loss functions we are using here, this will be same here. So this, you have to find that for everywhere you are getting different possibilities. So finally, this has all this have to learn in a back propagation, which is the best. Okay, so this have to be learned in a back propagation algorithm, that what is the best configuration of this weight matrix, what is the best configuration of this function f functions, what is the best configuration of this loss, everything will be learned using back propagation. Is it okay? This shared loss function, when I'm saying this shared weights, okay, this shared weight means these are all same. These are all same. So whatever weight matrices we are using here in this block, this will be same. So you have, for example, you are considering a matrix. Let's consider these two weight values, W1 and W. Okay, W1 is 5, W2 is 10. And then you are using W1 into X1, means 5 and 10. Same thing, W5 will be multiplied with X2 and 10 will be multiplied with H1. Okay, so now this W1, W2 values will be need to be modified according to your error. Okay, everything we need to adjust according to this total process, not with a single block. In multi-layer perceptron, you are using in a single block. Here you are using it actually full, okay, a set of layers, so everything will be processed together. Correct? Have you see? Have you got it? No? Okay, so you see this example, okay, so we will also cover in the next session some other more theories, and after that in hands-on, this all will be clear. Okay, so you will understand this, how, what are the weight values, how we are using. You can discuss with the with me in the hands-on, that how actually we are using. So all these weight matrix, this function, these are all same in every class. Okay, so you have now this simple block. If I just want to mention, okay, so if you see, you can try to visualize it now with a cell where this is the xt. Okay, this will be the xt. Xt is multiplied with v, some matrix. Okay, this is also weight. W is multiplied with this previous output, and then these are combined, and you are getting, okay, with some bias. You will have some bias. Okay, so you know this, in every neuron you have some bias. Okay, so whenever you are considering a neuron, you have this weighted sum plus bias. So you have this bias. Okay, so this is the total informations in this process. You have this input xt, for example, stack. You are just multiplying with some weights, and then you have this previous layers information. This is multiplied with some weights. Okay, so these are actually combined. Okay, so bxt plus this is the weight matrix into if you have this, for example, 3 input x1, x2, x3. So x1 into v1, x2 into v2 plus x3 into v3. And here w into ht. So in the previous layer also you could have 4 or 5 outputs. Okay, so in this, for example, from the hidden layers you can have 3-4 layers, 3-4 outputs. Okay, so all this actually could be could count. Okay. Okay, so you will have W1 into HT minus 1, W2 plus into HT minus 1. Okay, so whatever you have information you multiply, and then you will have some bias, plus bias. And then finally, this is the activation functions. This is it could be a sigmoid function, Danish functions, ReLU functions, or whatever. Okay, so these you combine them together, and then you receive this HT. The next layers, this is the previous layers outcome HT. Okay, this is the H1, and then you are getting this HT. Do you follow? This is the recurrent neural network. So we have, as I discussed already, FW, you can write like this: if HT equal to FW into HT minus A1, this we have already explained. So if you just make it unroll, okay, this full block. So if you have this H0, initially it was 0, H0, X1, and then we are using these functions, activation functions, we get H1. And then H1 and this X2, we combine them with a function, we get H2. H2 and X3, we combine them with their functions, we receive H3. Like this, we go on, okay, roll them, okay, one by one. We unroll, okay, one by one, and then finally we get the final H vector, hidden vector. Okay, so if you see this recurrent neural network, it's actually a sequence. Okay, this is a block of multilayer perceptron. This is another block of multilayer perceptron where this input is coming not only with these features but also previous informations. And this matrices, okay, this F matrix that I was telling, this W1, W2, all this WV, these matrices will be same, okay, throughout this sequence. This FW, whatever you have this weight matrix, these will be same. Okay, like you're in neural network, in multilayer perceptrons, you start with some sample random values, and those weights are actually modified, and finally you get this results. Okay, so similarly here, these FWs will be modified every time. Okay, these are actually same value. This will be a same value, same set of values, whatever weight values you are having. Okay, so if, for example, you are having 3 inputs and 2 out 8 zeros, so this 2 plus 3, you have total 5 Ws. This 5 W, here also you will have 5 Ws, here also you will have 5 Ws. This 5 Ws will remain same, okay, throughout this sequence. Okay, and then if you want to receive the outcome, so either you can receive from H1 to Y1, H2 to Y2, H3 to Y3, like this. Okay, and then you will have loss functions L1, L2, L3, L4 from each of these out. Okay, so what we have seen now, it's actually you are getting from input multi-input, but you are having a single outcome. Here we are receiving multiple input, but from each H1 we can also receive output, so that will be many input, many out. Okay, and this loss, whatever we have, this loss function, that is that from the difference from this actual to the predictions, these are actually all are coming as a total loss functions. These loss functions will be combined. Okay, all these loss functions, loss values are combined, and these are used in backpropagation. Okay, so if I'm just summarize everything, so if you want to have many inputs, a series of data, and you want to have one result, like a sentence, and you want to get one sentiment, whether it's a positive or negative. So you have a sentence, and then from each sentence each word of the sentence you give into the block, and then finally you generate the outcome is whether it is a positive or negative. Okay, so whatever loss functions you will have, you will learn. Okay, so here actually you will not have y1, y2. You will have finally this yt, because at the end you will have this yt, and this, and this sentence is having this positive or negative. So you find out the difference and you train. It is a many, it will be many to many, it could be one to many also. Okay, one to many also, I will give you an example. So one to many also, if you are giving an input, and this in the next layer onwards, there will be no input, but this output is only connected. Okay, the xi's are zeros. Okay, these outputs are only connected, and you are getting the results at the end. So from one input, you are getting multiple output. You can have multiple, many, one to many to one. You can have one to many. So you can have also many to many. Okay, you can get many to many. So that's actually, it will generate sentence to sentence. So for example, one sentence, you want to find another sentence. Okay, so from one language to another language. Okay, so if it is correct, so I'll just give you one example. Okay, and then we'll see that how actually it works. So let us consider that character level language models. Okay? So you have a set of letters, characters, HELO. Okay, set of words means in input it could be one of this character. Okay, input x1, x2, x3, x4. Okay, 4 input values in multi-layer perceptrons like this. If you consider x1, x2, x3, x4, one of these will be present, others will not be present. Okay, so this is called one hot encoding. One hot encoding means if you are seeing this H, then this first letter will be 1, others are zeros. E is in the second, so the first x1 is 0 and this x2 will be 1, others are 0. It is called one hot encoding. So you have basically 4 features, x1, x2, x3, x4. Out of this, one will be 1, others are remaining will be 0. And we want to predict the next letter. Okay? Or the total, the final word. If I just give HELL, it should generate O or something. Okay. So if I'm just, I want to generate a word hello. Okay. So what I will do, so initially my input vector is 1 0 0 0. Okay. And I start with some random hidden values. Okay. So this another set of values I said, this age, this I am considering as 0.3 minus 0.1, 0.9. Okay. Yeah. So you will have this 1 0 0 0.3 minus 0.1 0.9. And then if you give age, so you predict with this from this weight matrix, weight W to H, you multiply, and then you make an activation functions, you get some output layer. Okay, from this output layer, you make some softmax or some functions to receive this word letter E. So input is H, output is E. Now this E is coming as the next. Okay, when E is coming as the next, so that means 1 will be there. And then the previous information, hidden information is 0.3 minus 0.1, 0.9. So there in this matrix, you have basically two set of values, 4, 0, 1, 0, 0, and these three values of this age, 0.3 minus 0.1 and 0.9. So total input is 7 features. So weight matrix will be W1 to W7 plus bias. And this if you consider, and then you will have this another hidden layers, hidden values. Okay, the outcome of this hidden age values. And then from these age values, you make some output layers, and then you receive this softmax, and then you generate L. L will be here, used here, and this E is considered, and then similarly E and L are processed. You receive this values after this activation functions. You generate these results, okay, and then you get the results. Okay. Okay. So yeah. Okay. So you please tell me your problems, doubts.
Excuse me, sir.
Yes.
Hello, am I audible? Sir, the
Yes.
first layer, H I have given input. I have generated E. That how I generate E? Only by using the hidden layer, change in hidden layer, or I have given that E will be coming as a
See,
supervised learning.
Yeah, it's actually supervised learning. This RNN, whatever you are doing is supervised learning. So you
Okay, that means RNN will be supervised learning only.
No, it could be also unsupervised, but now we are considering it's a supervised learning.
Okay, thank you, sir.
Supervised learning. You have some actual levels, and from these actual levels, we find out the difference, and we want to get the error.
Right, sir. Thank you, sir.
There are also possible this autoencoders and many things are there. So this will be used as unsupervised. Yes. Say please your comments till now. If you have doubts, if you didn't understand, I will explain again. So we are giving, okay, this age. We then got E. E is given input, and then it generates L. L is given input, it generates L, and then L is given inputs, and it is finally receiving O. Did you follow? Any problems anywhere?
Yes, sir. It is okay. Clear.
Everyone, it is correct. Do you follow? See here, we are considering hidden layer with 3 outputs. Okay, so that's why you are having. So how many how many weights will be there? Okay, in this node, can you tell me how many weights will be there in this node? What will be the size of the parameters?
Sir, 3. As we are giving one input and rest there are 3 features E, L, O. So 3 should be the weights.
3 parameters, 3 W's.
3.
How many W's will be there? How many W's should be there? Yeah, how you can say that 12? Can you say? Yes, 4 into 3, correct. No. No, no, wrong. Tell me again. So how many W's? How many, what is the size of the input? What is the size of the input features?
4.
No,
4 by 1.
no, not 4. 4 plus 3. This is also input. 4 plus 3, 7. Okay, that's what I was telling, that you are using HT and XT, both you are considering to have this multiplication. Okay, HT is also multiplied with the W's. This XT is also multiplied with the W's. Okay, you have how many features here? HT is 3 set and 3 values. Here X is also 4. So how
4.
many values? 4 plus 3. HT is 3 and X is 4. So total how many inputs?
7 plus
7. Now you say that, yeah.
7 plus
into,
again bias is there.
yes, this also will be there. Now you tell me
Then
that
8.
7 is the input and outcome is 3. So it will be 7 into 3, 21. And then you have the bias. So you someone said something. Say 7 into 3, 21. Plus 1 will be there or not? There should be bias. As I was telling, okay. Here you see VXT W into ST minus 1 plus BH. XT is 4. Is it correct? 1, 000 means there are 4 features, okay? X1, X2, X3, X4. Either one of these is 1. Rest at zeros. So you will have 4 input. And HT minus 1, these are 3 values. And then you are considering 1 bias. So total, how many?
7, 3 plus.
Do you understand 7 into 3? Why 21 plus 3? 21 plus 1, right?
Plus 1. Only one bias will be there.
Only bias. Why you said, Amiyan, that 21 plus 3? In each layer node, you will have only one bias, right? Here only you are just having this. You see that when you consider it, that's why neural network should be very clear, okay? Multi-layer perceptor. You have this set of inputs you have some hidden layers. Okay, for each node, you are using this input. Okay, 7. So let me draw. Okay, so you have this 1, 2, 3, and these are 4. Okay, these are actually, you have this X. Sorry, my writing is very bad. And you have this H. Okay, so you have this another set 1, 2, and 3. So what you are doing, you have this outcome as 3, right? Finally, so what you are doing, you will have all these connections. You have 4 into 3. All these connections will be there. Okay, all these connections will be there, right? And then you use all this. You have actually 7 into 3. Yes, 3 hidden nodes. You are correct. Yes, you are correct. So you have 3 hidden nodes. Okay, so 3 hidden nodes. That means for each node, you will have 1 bias. So you are processing 7 into 7 plus 1 bias, 7 plus 1 bias, 1 bias. Okay, so this you are correct. Again, sorry. So you will have 21 plus 3. You are correct. So 21, and then for each node, so because finally you are having the output as 3. Okay, so for each output you have 1 bias. For each output you will have 1 bias, right? Yes, absolutely right. Virendra Singh. Yes, you are right. Yes. 7, 21 plus 1. No, 22. Output is 3. 7 into 2, 7 into 3, 21. Okay, 7 into 3, 21 connections. Okay, 7 into 3. And then for each connections, each output, you are actually having this bias. This means you are multiplying here all this 7 W1 into X1 plus W2 into X2 plus W3 into X2, like this, W7 into X7 plus B. Okay, so plus B1, B2, B3. Okay, so that's why you will have 3. These are not separate. Okay, so you will have this B1 you are getting from this 7. This B2 you are getting from this 7. This B3 this H3 you are getting from this 7. Okay, so H1, H3, so these 3 are output. So for each output, you are getting 1, you are having 1 bias. So you will have total 7 into 3, 7 plus 1, 8, 8 into 3, 24. Okay. So is it okay? So we can have the next sessions and then we'll discuss more. Okay. So please think of it again. So we'll see this now. Next we'll discuss these other problems. Okay, this back propagations and these other families of this RNNs, and we will also discuss those some of these applications.
Thank you, sir.
Yeah,
We
if you have any
will,
doubts, you can actually clarify.
Yeah. So
Yes. Yeah, any doubts? Anyone? See, someone wanted to say. Please.
participants, do you have any query that you need to ask right now?
Yes, yes, you can ask. They can ask.
Okay, sir. I think we will take a break, sir. You will also be tired. So
Yeah.
maybe like once more, we will get back at 12 o'clock in the other
Yeah.
next link, sir.
Yes, 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 yes.
Yes, sir. Yeah.
Okay, so
Thank
thank
you
you.
all.
Thank you. So
Thank
you
you.
can think
Thank
of this
thank you.
matrices, okay? So we can discuss again, okay? In the beginning of the next sessions.
Thank you. Thank you, sir. Thank you.
Thank you very much.
Thank you. Thank you.